Now to find the experimental Ka, I'm just using an example equation here of acetic acid reacting with sodium hydroxide. You've got your titration curve, and what we're looking for is the point of inflection where it changes from where the slope changes and your slope is undefined. So at that point where it changes from a positive slope to a negative slope, that's your equivalence point from inspecting the graph. In theory, that point should be when the moles of strong base are equal to the moles of strong acid. So what you do is you drop a line down, and this is your volume of base. So it looks as if it takes 30 milliliters of sodium hydroxide to get to the equivalence point. Now there's something very special about halfway to the equivalence point. At halfway to the equivalence point, in this case halfway would be somewhere around 15, so that's halfway. And halfway to the equivalence point, the pH is equal to the pKa. And you might be asking, well, what's the pKa? Similarly, how the pH is the log concentration of H+, that's pH. The pKa is the negative log Ka. So if I know my pH at halfway to the equivalence point, and again, this is only at halfway to the equivalence point. Okay, this expression is only true at halfway to the equivalence point. So if the equivalence point is 30, halfway to the equivalence point would be 15. And looking up here, my pH is pretty much close to 4 at halfway to the equivalence point. So if my pH is 4, that would be equal to the pKa and then I can do this to find the Ka experimentally. So if I plug that into my calculator and take the inverse log of -4, that 1 times 10 to the -4th, that would be my experimental Ka. Now you could compare that with the theoretical Ka. Now I know for acetic acid, the theoretical Ka is 1.76 times 10 to the -5th. So you can compare your experimental, which we got in the lab that we did, and compare it with your theoretical. So hopefully that clears things up for you all back in TV land. So this ends another riveting edition of Mr. Strauss's Chemistry Corner.